So this is the Miss S1 channel. We're talking about binomial random variables and when is it a binomial type of situation. So we know that what we need is for it to fit bins, BINS is what we're looking for. So we want to make sure all those conditions are met. So if we, in part A, if we roll a fair die 10 times and we define the random variable as the number of sixes we get, let's start with binary. What would be, we don't want to just say yes or no. What if it's yes, then why? Is it binary? What is that outcome? What's this? What does success mean? Yeah, so it is binary because success means you get a six, and fail means no six. You don't get a six. Independent. When you roll a die, are the trials independent? Yeah. So past rolls don't affect future rolls. So each roll is independent. Is there a fixed number of trials? And what is n equal to then? Yeah. N and P are the most important things here. N is 10. There's a fixed number of trials. And then S is probability of success. Is that fixed? And what is it? What is the probability of getting a 6 with a fair die? What is it? 1/6. Yeah, 1/6. 1 out of 6 because there's 6 faces on a fair die. So the probability is always 1/6. So yes, that is a binomial situation. We could answer any question about the probability of getting a certain number of sixes. And if something happened and it didn't fit, like the probability were really rare, then we would suspect maybe it's not a fair die. Okay, shooting a basketball 20 times from various distances on the court. Why is the number of shots made? So is that binary? Yes. Yes, you make the shot or you don't. Make shot or not. Independent. So we have to assume, he or she is not getting more tired as you shoot. So does making a hoop affect the likelihood of the next time you shoot? No. So that is still okay. So we don't want to be mistaken with the law of averages and think that just because we're making a lot of baskets that we're going to miss. Each trial is independent. Yes. Making shot doesn't affect later shots. And number of trials is, yes, n equals 20. Now, success, the probability of success, is that changing or is it always the same? It's changing. So no, and if one of the conditions isn't met, then it's a no-go. Probability changes. There's no fixed probability, so we can't do this problem using the binomial probability formula. And then the last one is observe the next 100 cars that go by and let C equal the color. I'm just going to tell you that is not, that is no, but why, what condition is violated? Everything. Binary, there's not either yes or no, a color. What else? Is C even a random variable? Is C even a random variable at all? What is the definition of a random variable? The outcome must be can it be a color? Yeah, it has to be a number. So C is not even a random variable because random variables have a numerical quantitative outcome and they have a certain probability of occurring. And there's not even a probability here. So it's just really not binomial at all.